Enterprise! Can you hear me?
Sky!
Out to Enterprise. Energize.
Engage.
Warp drive. A revolutionary technology from the Star Trek films that, for now, remains far beyond the reach of our current technology.
Make it so.
Imagine. With Warp 1 alone, we could make a round trip to the Sun in just 16 minutes. If we push it to Warp 9.9, we could reach Neptune in 4.9 seconds. Or a trip to Alpha Centauri in only 12.5 hours. In contrast, if traveled with the fastest rocket humans have today, that same journey would take 120,000 years. Just one way. But what is a warp drive really? How does this technology work? And in real life, could a warp drive actually be built? Get your coffee ready. We are going into a deeper audit.
Let's go.
Warp drive. Narratively, the term and concept of warp first appeared in a science fiction short story titled Islands of Space by John W. Campbell in 1931. It was later popularized by Gene Roddenberry through the Star Trek series in 1966. This is where the term warp factor became the global speed standard for interstellar travel. At that time, warp drive was pure science fiction. Until 1994, when a Mexican theoretical physicist named Miguel Alcubierre published a scientific paper titled The Warp Drive: Hyperfast Travel Within General Relativity.
And this is the idea I had. I called it the warp drive because it gave me a similar idea to what happens in science fiction. But it's this idea of warping space to be able to move fast, very fast. And there's no limit to how fast space can expand or contract. So in principle, you could use this sort of warp bubble to move faster than light.
Miguel proved mathematically that in a warp drive, Einstein's general relativity is not violated. How? By manipulating the geometry of space itself. Consequently, time remains the same for both the crew and the inhabitants of Earth. The law E equals mc squared can also be resolved. In his introduction, Alcubierre wrote, "By a local expansion of space-time behind the starship and an opposite contraction in front of it, motion faster than the speed of light as seen by distant observers is possible." He formulated what is now known as the Alcubierre metric, a model where the space in front of the ship contracts and the space behind it expands. Then, in 2011, Dr. Harold G. White from NASA EagleWorks brought this idea into technical reality. White discovered that by changing the shape of the warp bubble from a sphere to a thick donut, toroid, the energy requirement, which was previously equivalent to the mass of the planet Jupiter, could be slashed to the size of the mass of the Voyager spacecraft. In 2021, a team led by White accidentally discovered a real microscopic warp bubble structure while conducting Casimir effect experiments. This was the first time the fictional idea had physical evidence at the subatomic level. Yes, it is only at the subatomic level, but at least the idea that started from science fiction imagination can be tested scientifically. How does it work? Theoretically, a warp drive is not a conventional rocket engine. A warp drive is a medium manipulator. While rockets work on Newtonian principles or action-reaction, A warp drive works on the principles of non-Euclidean geometry. Warp drive manipulates the density of space around the ship through two simultaneous stages. Front compression stage. The engine creates a distortion that compresses space-time in front of the ship. Thus, a distance that should be millions of kilometers becomes very short. Back expansion stage. Simultaneously, the space-time behind the ship is stretched. The ship sits inside a bubble where space-time remains flat or static. The ship is stationary inside the bubble, while the bubble itself surfs on the wave of space-time. In theory, the ship doesn't actually move through space. Space itself is being moved. The problem is, to run this mechanism, components are required that exceed current technology, such as matter and antimatter reactors as a massive energy source, dilithium crystals to regulate the reaction so the energy doesn't explode wildly, and warp field coils, which emit that energy to form the bubble.
As we get closer and our conversations become more frequent, when you respond to this message, please...
However, besides the warp drive, there is something else that bothers modern science: the communication features. How is it possible for the crew of the Enterprise to communicate in real time across billions of kilometers without delay? If we refer to the speed of electromagnetic waves, just to say, "Hello," from Alpha Centauri to Earth, we would have to wait 4.3 years. This is where the concept of subspace comes in. Subspace is a continuous layer beneath normal space-time. If normal space is the surface of the ocean, then subspace is the depth of the water beneath it. Messages are converted into high-frequency energy waves to penetrate the threshold of normal space. Inside subspace, resistance to information approaches zero. These waves travel at a speed of warp 9.9999. Another unique thing is local gravity. In the Star Trek series, under the ship's deck, there is gravity plating. This layer emits a stream of graviton particles vertically upward to simulate Earth's 1G gravity. In fact, when the ship travels at impulse speeds of 75,000 kilometers per second, the crew isn't thrown back because of inertial dampeners. This system creates a force field that negates the effects of inertia. So, despite extreme acceleration,
Engage.
the crew can sit comfortably in their chairs.
Engage!
Now we come to the most important question. Can all of this be applied with current laws of physics? Mathematically, Alcubierre's solution is valid. The problem arises at the physical level. General relativity does not explain the mechanism materially. Warp drive might not fail in equations, but it fails because there is no physical model of space that can be engineered.
So, let's go back to Einstein. Einstein had this cosmological term. He said, "It was my biggest blunder. I want to throw it out, get rid of it." But the problem is you can't get rid of it so easily. Because using the miracle of modern mathematics, you can rewrite that equation. And now this is a small step for a mathematician, but a giant leap for a physicist. Not because it's that hard to put this term over there. Most of us could do that. But because it now represents something very different when it's on this side of the equations. Here it was somehow a geometric quantity. When it's here, it looks like a new contribution of the energy and momentum of the universe. What could contribute a term like this? And we know the answer. Nothing.
Subspace communication is also incompatible with the current vacuum model. Because in modern physics, the speed of information is limited by the structure of space-time. For subspace to work, the limit of the speed of light must not be a fundamental property.
The answer is nothing isn't nothing anymore in physics. Because of the laws of quantum mechanics and special relativity, on extremely small scales, nothing is really a boiling, bubbling brew of virtual particles that are popping in and out of existence in a time scale so short you can't see them.
As for local gravity, current science is stuck. General relativity states that local gravity can be created if there is a massive amount of mass or extreme energy.
This is Einstein's profound insight. Gravity is not a force between objects. Gravity is the curvature of space and time. Massive objects don't pull on other objects. They warp the space around them. They bend it, curve it, distort the geometry.
But the Enterprise doesn't have the mass of a planet beneath its floorboards. So, in conclusion, this technology will be difficult, even impossible to achieve, if we still refer to old dogmas. But I will try to offer a new idea. This is a purely untested idea, but it could explain why this technology makes sense. This idea is a particle that is similar to ether, but is not ether. For an initial hypothesis, I name it the Leela particle. Observe the pattern. Warp drives, subspace, and local gravity all require the same thing: space that has active physical properties, not just empty mathematical coordinates. Aristotle said space is never empty. Newton said space is an absolute container. Maxwell proved waves need a medium. But Einstein discarded the medium and kept the geometry. The Leela hypothesis emerges right in this gap. Leela assumes that space is a cosmic physical medium. It has density, pressure, and dynamic response. In this framework, warp is a pressure gradient of the medium. Subspace is an alternative propagation mode. And gravity is the effect of the medium's interaction with matter. Leela is not yet an official theory, but it provides a physical mechanism, something currently missing from ambiguous modern physics. And that is the difference. This is not fighting the laws of physics, but trying to fill in the parts that are still empty. For a detailed discussion about the Leela particle, we will discuss that in the next episode.
If I'm wrong about that, then you're going to have to do it with me on board.
Actually, Carol, I won't.